In recent videos, we've looked at how to create objects inside of C++. One of the things I found helpful when learning a new language is to look at how a developer of that language creates some of their own components that you can use. So let's take a look at something as simple as a string in C++. Now, there's actually two different ways of creating a string. The first is to use an array of characters, and that's sometimes referred to as a C-style string. And we actually use those anytime we use a string literal. Now, for the sake of what we're going to look at, because we're looking at objects inside of C++, is we want to look at the class string and how we use those two data types. So let's look first at two different strings and the way we can create them. First, I have string S1, and I assigned a value, this is a string, to string S1. And then I have S2 putting this is a string as a constructor. Well, would you believe that these two, while they do the same thing, are not necessarily equal? One is actually better. I'll give you a second to think about which one might be better. If you thought it was the first one, I'm afraid you're wrong. You see, what the first one does is it creates an empty string and then reapplies a value to it, creating a new string object discarding the last one. That's the way strings work in C++, is you can't simply modify them. You a lot of times have to delete the old value and put in a whole new value. Where with string 2, that value is immediately assigned as the object is created. So it's one less step and just makes it a little bit faster. Now you might say, well, how does it do this? Well, one of the things that it does is through operator overloading. And it overloads that assignment operator to make it faster and easier to use. And we're going to look at how do we do operator overloading inside of C++ in just a little bit, because that really simplifies it. Most people create strings via the S1 method because it's simple and it's easy, even if it is just a little bit slower. We want to look at how to do things quickly and easily, the same way that the C++ developers create the string object for us to do it. We also want to look at how does C++ make it easy to work with our strings. Well, they give us some very helpful methods. And anytime we want to create a class inside of C++, or any language for that matter, we want to look at what methods will make it easy for our developers to use that object. So let's look at some simple methods. We'll start with cout. We're going to say s1.at, and this allows us to define what character we're going to display. So I'm going to simply choose 3. This at method allows us to find what character is going to be stored at index 3. When we run it, we see it's the character s. Now you might think, but it's supposed to be this is a string. Shouldn't it be I? Well, remember, our indexing starts at 0. So index number 3 is actually the 4th element. Other things that we can do with our string is we can append things. So for example, let's output S2, and then let's modify S2 just a little bit. And append is a perfect example of a way to modify our object. Append is a natural name for a method because appending allows us to add information to the end of our string. So if I say append, I have, you'll notice, several different ways of doing this. For example, I could append a string. If I go through and Visual Studio allows me to view the overloaded methods, I can also see I append a constant character with a number of times and size and some other things. Notice I have this as a string, just as I did before, and then I append the other string. It doesn't overwrite it, it appends it, adding it to the end, just as its name would imply. Now, to keep from boring you with all the different appends, let's look at some other things we could do. For example, replacing and inserting some values. So here we have a string S called welcome to my world. I'm going to print that value out, and then I'm going to use the replace and the insert to see what's going to happen. Now, I'm also going to take this and print S at the end to see how things were modified and if the value was saved or if it just put it into the output string. Let's run this real quick. If we put our output next to our code, we'll see that it says, welcome to my world, which is that we expected. We then have a replace where we say instead of world, it's going to be life. And that is what happens. Now, the replace is going to change out a value, starting a specific character and showing how many characters to replace. Insert, on the other hand, is going to modify and change it so that we insert text into it. Here we say my a second time. And notice with each one, the value of S is actually being updated and changed. That way, it stays consistent throughout the process. So when I print out S again, just like I did the very first time, I see my last string. This is a consistent behavior that we'll see with a string object, which is another thing we want to look at, is we want to be consistent with how objects work when we use them. One thing that developers often need to do is to work with substrings of data. A substring is just a part of a string. So here's an example. Once again, we start off with welcome to my world. And we want to print out the substring of what happens if we start at character 15. Finally, we also want to look at what's going to happen. In our second example of printout, we're going to look at what happens if we start at 12 and only print out 2 characters. Should print out my. That way, instead of just giving a starting location, we give it a number of characters we want to print out. Because we're looking at the substring, we're not modifying our string. So I'm going to finally print out S and make sure that our whole string is intact. Let's run this real quick. When I put my code output next to my code that was generated, you'll notice that world with the period is put at the end like you would expect. With the substring with 2 parameters, I get the value of my, and I also have a wholly intact string when I do a cout of S, just as I would expect. This is how C++ is going to use substrings. Substrings is letting us know that we're returning a value. And in returning a value, we're not modifying our value. So this is expected behavior. In the same way, anytime we create a class, we want to make sure that if we're going to export data out, using something like a getter, we want to make sure that we don't modify our data. This is a perfect example of that. And while most of our getters are going to have get in front of it, not all of our data will. If we look at other C++ string classes, we'll find methods like empty, which returns if a string is empty or not. We'll also find things like clear and delete to remove our data. We have here listed an example of other string operators that are overloaded. And we could overload a lot of our strings and string methods very easily. This allows us as a developer to work with our strings very effectively, and something we want to keep in mind whenever we're working with our code. Overloading makes working with objects much, much easier. And so anytime we can do that in C++, we want to take advantage of the language and its operation efficiencies.